I'm going to assume that if you're watching this video, it is because you're a SUNY Geneseo student or somebody taking Calculus 1. You are interested in the definite integral. You have seen a video that talks about the definite integral. You have seen the definition. You have played with Riemanns that you're hoping, do I have to do that on the test? No, you don't have to do that on the test. You do have to know that these things have limits as n gets large. That you have to know about. You have to know how to take a limit of this as n gets large. That you have to do. And then integrals as areas. You have to know how to graph a function and find an area. Graph a function and find an area. Graph a function and find an area. Now area is always positive, but area above the x-axis generates positive integral values, and area below the x-axis generates a negative integral value. So some negatives and positives sort of cancel each other out. That's an important thing to know. Area below the x-axis, area above the x-axis, negative integral value, positive integral value. And when we covered this, and so then you clicked on the worksheet in Canvas and you took a look at these things. I would like to do the odds for you. The evens are similar, or maybe I'll do the evens and the odds you can do, or maybe I'll just pick as we go. So if I may, let's do this. You graph the function y equals 2x, it looks like this. There's 0, there's 3. When we write the integral from 0 to 3 of 2x dx, we mean the area bounded by this function and the x-axis from 0 to 3. We mean this area. That's the area of a triangle. The area of a triangle is 1/2 base height. The base is pretty clearly 3. The height is whatever this height is. Well, how tall is that height? What are the coordinates of that point? How would we know the coordinates of that point? Oh yeah, we know it because that's the equation of the line, so that's the y value. And if that's the y value, that's the height. And sure enough, the area turns out to be 9. You have to recognize that this is the function we're graphing. We're finding the area bounded by that function and the x-axis on the interval they gave us. That's a shape whose area we know, and we can find the area of that shape. Similarly, that area is 9. 3 or 4, heck, this time I'll do 4. 8 minus 3x looks like this. We're interested in the area from -1 to 2. To be clear, this happens at 8/3, which is almost 3. So we know that 2 is over here. So the area bounded by this curve and the x-axis between -1 and 2. That's this area. That's the area of a trapezoid. And the area of a trapezoid is 1/2 the height times the sum of the bases. This trapezoid is a weird shaped trapezoid, right? It looks like this. So the height is actually this part, and then your bases are those parts. So the height runs from -1 to 2, and the bases are these two lengths. Well, how do you find those two lengths? Well, that's the function you graphed. So when x equals 2, the y value is 2. And when x equals -1, the y value is 11. So the bases are 11 and 2. That's 13 times 3, 1/2 of that. That's the area. And so the integral from -1 to 2 of 8 minus 3x dx is 39/2. Similarly, this integral value is 24. It's a trapezoid, and you should be able to figure that. Question 5 asks us for the integral from 1 to 5 of x minus 3. Well, what does x minus 3 look like? X minus 3 looks like this, where it hits the x-axis at 3. So here's 1, here's 5. We're interested in the integral determined by these regions. Well, this triangle is congruent to this triangle. And if that's the case, then this area above the x-axis is some positive number, and this area below the x-axis is the negative of that number. So that integral value is 0, because the area above the x-axis generates a positive integral value, and the area below the x-axis generates a negative integral value, and they are the same in area. So this integral is 0. Similarly, this integral is 0. Okay, one other to talk about, and that's the square root of 25 minus x squared. If you were to graph this on a machine, you'd get something looks like this. Why? Because this is the equation, too early. This is the equation of a circle. Centered at the origin, radius 5. Centered at the origin, radius 5. We're interested in the circle goes like this, but we're only graphing the positive part, so we don't even graph this. And we're only interested in the area between 0 and 5, so we're only interested in this part. This part is a quarter circle, and a quarter circle has area 1/4 pi r squared. Well, what's r? That's the radius. That's this. And so this integral has the value 25 pi over 4. 25 pi over 4. If you were to graph this function, you get something that's basically a rectangle with a triangle on top, and that area turns out to be 9. Hopefully this is enough of a jump start for you to be able to fill in the rest of the gaps, maybe hit the questions in the OpenStax text that I had talked about on Canvas. This is a super important lesson for you to do. Hope that it is valuable to you and that some geometry comes flowing back.